So please, it's a great pleasure to welcome everybody here to Diiesl, to the Diiesl seminar. This session is all around, well, we've got a range of people, but the idea was broadly around interfaces, API economy, ecosystems, and the idea of this extended digital ecosystems work. And we've got amazing set of 4 speakers today. First of all, we've got David Pym, who I'm just going to, who will be just giving 10 minutes on Iris, who are a sponsor of this Diiesl program. So David's going to introduce that. And then we've got Nigel, who's going to talk about his research. Rosaire, who's also on the Iris project and works with me on some really interesting work around travel ecosystems. And then Hans at the end as to talk about his research and introduce the work that he's been doing in this area, particularly around the ecosystem work I think Hans is talking about. But it's great to see so many people on the call. I'm sure more people will join. But straight over to David. David Pym is a professor at UCL in mathematics and logic, and we've worked together for, gosh, many, many years.
Many years now,
on various things.
Yeah. Okay, give me a moment just to do the screen sharing, and I'll be right there.
Let me just check. Yep, everyone should be able to share.
You've disabled screen. There we go. That's good.
Just to tell everybody, the session is being recorded. We haven't got all the agreement from the speaker, so we're just trying to work out what will be available later. But if you have any problems with that, just please be aware that the sessions are being recorded. Thank you.
Okay. I need to just get this going. Okay. Is that
at the moment, David? We can see your presenter notes, which is
okay. I'm having trouble getting it to do anything else.
That's fine.
There are no notes. There's nothing secret anywhere in the slide, so I guess it doesn't really matter.
No, so, go ahead.
Okay. So, thank you, Will, for the introductions. I'm David Pym from UCL and the Institute of Philosophy in the University of London. I'm a logician, which is why I hang out in the Philosophy Institute as well. I'm going to talk about the IRIS EPSRC program grant, IRIS standing for Interface Reasoning for Interacting Systems, which involves not only people from UCL and LSE, but also from QMUL and IC. So all the way across London, really, east to west, not south of the river, but that's, you can't have everything. Okay, so I run the IRIS grant, and Will is the investigator at LSE. So what are we concerned with? So a very famous person from the US Navy called Grace Hopper once said very cleverly that life was simple before World War II, and after that we had systems. She's particularly famous in the world of computer programming because she discovered the first bug in a computer program. In fact, she found this moth in relay number 70 in panel F of a computer she was trying to fix. Anyway, there's the moth. That is the actual first bug in a computer program. Anyway, that's why she's really, one of the reasons why she's really famous. She's really famous because she did a lot of really cool stuff. Anyway, she said that, systems were an issue. Well, things have changed after the advent of the internet, because we don't really just have systems anymore. We have ecosystems of systems. So we have all these systems that are pervasive, and they interact and depend upon one another, and we depend on them. And it's therefore imperative to think of and reason about ecosystems as entities of study. Now, if you think about what it means to be an ecosystem, it's a composition of systems, but those systems themselves are probably compositions of subsystems. So you've got a whole load of things all talking to other systems, and in the end, it's easy to think of really that everything really comes down to being an interface between systems, and there's not much else really other than interfaces between systems in the end. So interfaces are kind of important. So that's why we're looking at them quite seriously. So what is IRIS about? So we're concerned with understanding and reasoning about ecosystems and the interfaces that connect them together. We are concerned with systems at all scales. So that would mean in computer terms at code level, from how does one module of a program interface to another module of a program? How does one program pass on its computation to some other program to be used. Through the through the kinds of systems that make your kind of computer networks work, the servers and the file servers and all that kind of stuff, and the network that connects them together, through the kind of systems that commerce and big tech use, like great big distributed databases and all of the things that make everything distributed these days work, but also up right through to the structure of organizations. So this is where we become much less focused on technical things and much more focused on organizational structure. I'd like to emphasize that our view of systems certainly encompasses policy and human components as well as technical components. We're absolutely not focused on purely technical things. We certainly, I'll give you another example later, but we'd certainly consider the architecture and processes that enable people to get from the car park at an airport through to being on the aeroplane and flying away to be a system of interest, and that would involve all sorts of technical and socio-technical and policy components to make it comprehensible, and certainly involves an awful lot of interfaces between different bits of the system. So our techniques for thinking about all of this certainly come from logic and from computer science, but also from economics and information systems and much more. And a very important idea that actually comes from computer science is the idea of a distributed system. So the idea of a distributed system is that you have an architecture of resources which are connected together somehow, and communication happens between those located resources, and as a result of the manipulation, that is, things like the consumption, creation, moving of resources, a service is delivered by the system as a result of all of that. But of course, a service is delivered only by interacting with other systems, outside of the system that's actually doing the service. So it's a very good metaphor for us. It's also a metaphor that is very robust in that it maps naturally onto most of the kinds of systems of interest for us. And it's also, in order to do that, of course, it has to be scale free. It doesn't really matter to us whether the location we're talking about is a memory cell in RAM, or a location of a city on a map, or the location of a department of an organization within a building. In terms of locations, they all have essentially the same properties. They all are places where resources live, and they're all places which support the execution of a process to deliver a service, in some sense. So at that level of abstraction, the distributed system is very convenient for us. The techniques we use, well, mathematical modeling is a very important technique, and one of the things, mathematical modeling drawing perhaps slightly unusually on techniques from logic and the theory of computation, as well as economics and information systems, in contrast perhaps to the more common conception of mathematical modeling around, modeling the stresses and strains within a bridge, or the spread of a virus using dodgy epidemiological models, or whatever it is that's going on. So, that tends to be a different kind of mathematics. Here we're very much more concerned with the representation of structure and the relationships between structures. So that is a slight difference from perhaps the common experience of mathematical modeling. But one thing we are certainly trying to do is to push this idea of modeling rigorously into the more socio-technical aspects of systems and ecosystems of systems. So here we are. So just in a little more detail, so what we're concerned with is how systems compose with apologies for the typo, with one another to form ecosystems. So one thing, so we're interested in how we can identify what are the interfaces between components. How can we design interfaces between components? In other words, what does it mean to be an interface between? Where does the system start and its interface to other systems begin? How are we going to reason about properties and behavior of interfaces? So when you've got some big complex composition of things, in order to reason about how two of them can be composed and communicate with one another, one doesn't have to want to reason about all of the structure of all of those two systems. That is a massive conceptual and technical and computational overhead that one doesn't want to incur. And and it would actually be very unhelpful. So what we want to do is to be able to isolate the reasoning we need to do about the composability of systems to reasoning about the interfaces that facilitate that composition. And this is an idea of local reasoning. And this is actually an idea which has been developed very extensively in the world of program verification in recent years, in the last decade or so. And around the idea of 2 decades, actually, around the idea of, time flies, doesn't it? Around the idea of something called separation logic. So separation logic is something which is an area of mathematical logic which allows one to understand how different parts of a system are separated from one another and behave independently of one another. So this idea of local reasoning comes from there, and it's important to us to be able to concentrate the reasoning about composition we need to do on the interfaces between systems, not on the whole of a system. So that's important for us. From our point, security, which we can see as a generic perspective on systems. I mean, if you think of security as being about things like confidentiality and integrity and availability, then you pretty much have to understand all aspects of the system in order to think about those things. So, so it's a key application that gives a very useful perspective and lots of interesting examples for us. So we're very interested in that. One of our key collaborations, which is with HP Labs, is around security and policy from this compositional ecosystem point of view. And another industrial collaboration is with BT, the very large UK-based telecoms company. And there we're more focused on organizational structure and policy. So that's very much a very social and technical perspective. Okay, so that involves a big collaboration between BT and LSE and UCL. Okay, so finally, a last slide. ILIS is indeed very highly interdisciplinary. We draw on ideas from logic and semantics and theory of computation, from the theory of systems, theory and practice of systems, from ideas around program verification, from the perspectives of information systems on organizations and how they operate. And we draw a lot on ideas from policy and economics to try to understand how things are organized the way they are and what value they deliver. And all of those things need to make sense from the point of view of the compositional structure of a system if one wants to understand that properly. And just by way of a final remark, I would say the collaboration between the formal modeling, the mathematical modeling, which is really based in UCL, and the information systems perspective, which is really based at LSE, is proving particularly useful and effective for this project. And it's a great pleasure to be working with the LSE folks on this. Thank you, Will.
Thank you. That's great. And yeah, and it's great to have Iris's support for Diiesl, which we would be funding the drinks after the event and the room and everything else, but obviously that can't quite happen, but maybe someday. Thank you. I'm going to move on quickly, if I may, because we're slipping behind time, and I don't think this, I mean, we can ask questions around Iris later, perhaps, but I'd really like to introduce Nigel. Nigel and I have had great conversations around this idea of an API economy, and I was particularly keen that we have Nigel represented when we're looking at interfacing because of the research he's been doing with his colleague Rajiv, who's also on the call. And it was just great to be able to have him present. He grew up apparently in Berkshire, but the way he pronounced it suggested it was only for 2.5 years, and he might have been rather young at that point. He is a professor at Michigan in the Ross School of Business, and well known to many of us in information systems for the various writing that he's done across the years. So Nigel, straight over to you, please.
Thanks, Will, very much. Let me share my screen. Okay, sharing done. Now let's move things around.
We can see that, that's great.
Excellent. Let me do one more thing, call up the chat so I can see everyone here.
Yep, people have already started posting things, which is nice.
Excellent, yeah, okay. So, there we are. I think I've got it. Right. Okay, we're all set. Thanks, Will, and it's great to be here and see everyone. Welcome to my talk on generating business value from machine interfaces. This talk is a joint collaboration, as Will said, with Rajiv Kohli, and it's based on our forthcoming article in Management Information Systems Quarterly Executive, MISQ Executive, coming out next month. So just a high-level view, spend a bit of time on motivation. Most of us understand why these interfaces are so important, so I'll go rather quickly through that. The methodology is case-based, just one slide on that to give you a sense of how we did that. Then we'll move into, most of our discussion will be on the results. Okay, so if we think about modern digital systems, like a digital twin or a smart speaker, we think of two features that are quite important or salient. One is the capabilities they offer. So for example, the ability to see and understand what they are looking at, the ability to listen and understand what they are hearing, and the ability to make inferences and decisions about the past and the future. These capabilities are embodied in systems that we call AI or automation. But the thing is that in order for these, Tesla, digital twin, etc., to enact those capabilities, they must coordinate with other systems, as we just heard. What does coordination mean? They must share resources to achieve a goal. Okay, so that's the arrow between them. Capabilities are enacted through the coordination of different systems. Now, why is this important and why is one box a bit darker than the other? We have an enormous amount of research in the field of information systems on the left box around capabilities, and we have only a small but growing amount of research on the coordination aspects. And I submit to you that coordination is equally as important and is well deserving of more research. We can think of that in two ways. One is conceptually and one is economically. Let's think about language for a moment, the importance of human language and thinking about digital interfaces as a way for machines to communicate with one another. Language has played a prominent and possibly preeminent role in our species history, the relative genetic homogeneity of humanity, in contrast to our cultural diversity, shows that our oral DNA has probably been more important in our short history than genes. So this quote, I want us to remember this throughout my talk, because this really underscores the possibility of a kind of universal language of digital interfaces for machines. Okay, so let's think about that as a concept. Now, most of us are familiar with the economic value perspective of machine coordination or digital interfaces. So enabling app functionality, enabling, cloud system integration, new sources of revenue and efficiency, and even competitive advantage and compliance. So for example, PSD2 in the EU for financial data sharing, or what Maersk is doing in global supply chains with APIs and trade lanes. So we should probably have a definition here very quickly. The way I see that, the way Rajiv and I are looking at APIs or interfaces is that they enable machine coordination. So APIs is a particular form of digital interface enabling machine coordination, simple, standardized, loosely coupled means by which to expose and share capabilities, so or resources, data, functionality of one system with another, and more loosely speaking, language for modern digital systems to interact. And again, when I'm discussing this with colleagues from areas outside of information systems, this idea of a language as a metaphor is much easier for them to understand. So when we think about digital interfaces, we often hear examples of these tech companies, like Airbnb and Amazon, same old story. So, but really a lot of very interesting things are happening outside of tech sector. So let's look at some fun examples. In olden times, we had cans of soup and we had recipes on cans of soup. And now this company, which is very well known, Campbell's, has an API library where anyone can, for free, access all of the recipes from all of the products. So this opens up a kind of ecosystem for innovation, for others to blog about this and expose and drive revenue. Another example is prescription refills. So in old days, we would like go to the pharmacy, or we would call, like we see in the picture here. In today's world, we use pharmacy prescription API, right? So now we can have a third-party app that uses the shared capability of prescription refilling, and anyone can access this, and this sort of creates another service. So two examples. Now, beyond two examples, my friends who are economists might say, well, these are great examples, but this doesn't prove anything. So I'll leave you with this final point, which is a recent survey of enterprise IT leaders. Okay, so the ones that are leading the pack, 31% of revenues come from APIs or services implemented with their use. So 1/3 of revenues in companies outside of the tech sector who are leading with technology get approximately 1/3 of their revenue from these digital interfaces. So that's quite significant. So if we step back, we say, what is really going on here? Cloud integration, exposing resources, branding, smart products, platforms. We'll hear more about platforms from Rosaire and Hans. So what are really some important questions here? Many questions. We need more research. And here's where we focus. So our research question, how do large non-tech sector organizations generate business value from APIs? This is where we're focusing, although there are many other important areas that also need research. So very quickly, methodology. So methodology is sort of the lens we use as well as where we train the lens. So it's both. So we started with a kind of a background, right? So let's read up on, industry publications. This is a very hot area. I'm sure Will and others are familiar with this. We took trips and interviewed CTOs of API management platforms. One of them was MuleSoft, which was recently acquired a few years ago by Salesforce. And that also indicates the capabilities and coordination, right? And then we had also discussions with tech leaders. What we found from all of that was that there were many companies that are using APIs at kind of low levels for like basic things. Then there are some companies who are at the very high end, and then sort of a spectrum in between. So we said, let's try to find some cases that represent in some way that spectrum. So one may be at the early stage, one that is much more sort of mature and advanced, and then one in the middle. So we found 3 companies, healthcare distribution and services. We interviewed individuals at the sort of high levels of these companies from both the business side and the technology side, totaling about 10 interviews, almost 10 hours. We did the sort of standard analysis, open and axial coding, and basically looking at tags, rolling them up into themes, and then naming these different models. Then we did a validation step of presenting our work to executives and getting their feedback as well. So that's methodology. Let's see. Okay, so now we go to results. Right, so I'm going to give you the kind of TLDR, the high level 2 results, and then I'll go into some detail. So the first result is that the value of digital interfaces in large non-tech companies derives from what we call an API infrastructure. So when we talk about digital interfaces as instantiated by an API, we think of API like, okay, this is some program code. I can call some data, or I can call a capability, tag this photo, for example. But really, it's an infrastructure. And what is the infrastructure? The infrastructure is people, process, and technology. This is what we found in our interviews. People side, training, incentives, development approaches, a culture, how they actually view the API, right? Business mindset, processes. So this is governance, security, product management mindset, these sorts of things. And then the technology layers. So one technology layer is, if you think about APIs as a portfolio, this is a set of APIs in a particular organization. Companies need management technologies to manage the portfolio. And these are the management technologies here, like API gateways, API management platforms. So this would be like Apogee or MuleSoft in the market, right? And then what is the functionality? So creating, publishing, load balancing, encrypting, documenting, analytics, right? All of these are possible. They're not all enacted by firms, but they're possible. And then finally, the API itself. Think of it as one member. If this were Netflix, the API would be one single film, and the API management platform or the sort of technologies would be like the Netflix platform, okay? So any questions on that? Is that good? Is that clear? Okay. Right. So
It's
the
clear.
second, okay, cool. So
And I
second
think
high
it's
level.
really important that people understand that, because I think we just think of APIs as being pipes. And I think that's a really useful structure.
Yeah, I agree. Thank you, Will. And this was quite strong when we interviewed companies. I think, Carlos, if you could mute, thank you. In companies, we heard this again and again, especially from the business side. They have a view of APIs. They have some knowledge about this, but often if it's not done according to like a coordinated campaign and it's not strategic, they have some myths and some misunderstandings, and that causes.
MuleSoft have been really influential, I think, in building that. So it's good that you're.
They have.
Yeah.
They have. Yeah. Okay.
Sorry.
So now the second high level finding is we found these three models of value creation: efficiency, focused, and transformed. One is not better than the other. Each has a different level of API infrastructure investment and return. So they're different choices that firms make. So let's take a look. So model one is what we call the efficiency value model. We found most firms in our background research, as well as the firm we looked at, there's a very large number of firms that basically use APIs. They consume them for two purposes. One, for cloud system integration. So like a firm gets a new cloud ERP and they have to connect that to all the other systems, and it's a necessity to use these APIs for that reason. And then the other reason is development or developer productivity. So this is like, oh, we need a new mobile app for our field reps, and we need to pull in things like maps and things. We pull them in through APIs. So this is very basic. It's small investment in the API infrastructure, and it's also a limited sort of value generation. And again, around sort of integration, programming efficiency, and sometimes reduced time to market. So it's not a strategic focus. So if we think of one company that exemplifies this model, $10 billion US service organization, the drivers were cloud system integration and mobile app development efficiency. How did they do this? They have an ESB. They actually have multiple API management platforms, which indicates a kind of non-strategic approach. And importantly, there's no clear governance. There's only a minimal communication framework, and it's kind of a build it and they will come attitude. So it's not so surprising when there's not a marketing campaign or communication campaign or an overall vision that many in the organization, or most, have no idea it even exists. Okay, so this is very basic level. And then the outcome is programming efficiency. But again, when you ask these individuals, the respondents, so can you give us metrics? Do you have analytics? They don't have them. They say, oh yeah, we have, the platform has those, but it's difficult for them to give you, right? So you can tell if it's difficult to give to me, a researcher, it's probably also difficult to give to others, okay? And then cloud integration. So that's the first example, efficiency value model. So this one I think is pretty clear. So if we plot this on a map and see where we are, IDC conducted a survey recently that said about 40% of companies are in this kind of efficiency model, okay? Meaning very, very basic level of investment and return. Okay, so now let's go to the second model. So the second model is what we call focused value model. So this is companies who are strategic about APIs in a particular line of business. Okay, so they have quite a bit more API infrastructure investment. They have ESP management platforms. They have systematic governance and security. So these companies, every single one, build security in from the very beginning, even going so far as to purchase a private network for the API data transport. So they take it to that level. It's not just OAuth and secure authentication. It's actually in transport as well. So systematic governance, a clear vision, communication strategy, the motivation for change is clear, and an outside-in mentality. So now it starts to look like API as a product, API as what do our business internal customers and external potential customers need? How can we serve them? It's a very different mindset. So the value is deliberately generated and clear, business unit driver, loosely coupled, efficiency, revenue, and differentiation. So this model is where we start to see monetization and externalization of APIs. Okay, so now we have a US building supplies distributor. Okay, so what was the driver here? Business partners, meaning internal to the company, are starting to say, we are collecting all of this data from different channels. We have the online B2B, we have the B2C, we have internal, we have other channels. We know the data are there. I'm a marketing person. I'm a optimizing supply chain management person. I need the data to make better decisions. And the company was not able to give the data. Why? Because the data are connected and they are not loosely coupled. So the data and the service are tightly connected. And if somebody wants a new service with the same data, it's difficult to do. So that's the driver here. It was in one particular focused area around e-commerce. So the strategic thinking is locate the API management under the Chief Information Security Officer. That is actually where the API infrastructure is situated in the organization. Very rigorous risk management, scalable security, Sarbanes-Oxley, and so forth. The idea of capabilities as a service. So in this model and the subsequent transform model, companies are starting to see APIs as components that they can bundle into meta services and either sell those or partner with other firms to expose those. So we're starting to see the notion of bundled APIs to encapsulate a larger, more value-added set of services here. So what? So as I said, we have bundled connections and capabilities. We have a product and a service mindset. In this case, it was around shipping processes owned by the business and the technology product managers. Innovation at the edge, meaning exposing and allowing business people, the marketing, the finance, to actually use those APIs themselves. So like self-governance, build in the security guardrails so they actually cannot do something that would be out of bounds for the security guidelines, okay? And using things like low and no code API integration. So this is where we're seeing that. We have layers. They have showed us a layer module or a layer schematic. Security apparatus is like a fence around the organization. It's baked in. Governance aspects. Business governs those for governance. And then expressing capabilities in both a machine and human readable way. So this is really a big shift here. Big shift. And then the example they gave us was an omni-channel API-enabled shopping cart as a product. So before this product, we had a shopping cart where a field representative or a B2B partner, they would go and put something in a shopping cart, stop the cart. We've all had that experience. We stop, something else comes in. Then we move, we're in store, we don't see it anymore. They don't have it at the front, okay? So this now moves this shopping cart wherever you are and makes this kind of experience for customers much easier, and it makes more sense. Okay, so we're moving up now, the Campbell's example in exposing their recipes on the cans and some other companies, but that's basically the focus model. Maersk looks a bit like that. As far as we were able to tell, Maersk is focusing only on shipping, which is their core business, but they also have other lines of business, and we don't know the extent of API use there. So final model, so I'm going to speed up a little because I think I still have about 10 minutes. The transformed business model is a step further from focus. These are companies that follow what might be called an API first model. These companies are basically taking a traditional company and making it look like a tech company, both in the front end, so the APIs, as well as the underlying infrastructure, going from these large applications that have been existing for decades to microservices structure. So it's a smaller kind of applications that are knitted together and APIs talking to one another. This is how companies now like Segment and Twilio, so-called API first, this is their entire operating model. So these companies are starting to look like that. So what does it really look like? It's the foundation of digital transformation across the entire firm, all areas towards industry leadership. These are companies that want to be a platform or an ecosystem. This is their goal. So we have most or all data is unlocked and provided as a service. It's an ethos, a culture. Everyone talks about it. There's a kind of, they usually have a champion who is like a TED Talk type of person who is just talking about this all the time. There's a virtuous innovation cycle. The more data are shared, the more people understand this shareable, the more they use it, the more they request and so forth. Capabilities as a service again. So again, we are exposing capabilities via APIs. We have a Lego approach to services to cut development costs, and then opening data via a services stack for customer satisfaction. So disaggregating the service from the data and allowing others to build new services off existing data. So a healthcare system we looked at, they're going after competitive differentiation. They exemplify a lot of the features that I just discussed. They have an evangelist who is a dual MD CTO, sets the vision, assembles the teams, and really understands the possibility of APIs and the services that follow from that. There's a revenue play here, new business models in terms of business partners. So companies in the transformed model are able to partner with other firms, and the core of the partnership is a bundle of APIs that can co-create value with another company. That's a very different model. So for example, a mobile health app that looks like it's coming from your local health service, but it's really created on the back end with this third party because the APIs allow that. Industry leadership, and so forth. So this is at the top end of the scale. And just to give you a sense for the involvement of non-technical personnel. So when we think about other business units, we can think about business services governance. We can think about self-service capabilities and exposure. And then we can think about low or no code development. So this indeed spans both the technology services and other business units such as marketing, finance, etc. So there we are at the top. We see the healthcare company and others, Siemens, Capital One, Scandia Bank in Europe, and others are really going for the transformation. What percent of firms are in the transformation model? It's difficult to say. We don't know because we don't have the research to be able to say. Okay, few insights beyond the models. So insight one, what we found is many of the EDM firms are going to encounter challenges if they try to move up the curve. So for example, they have a mindset in both the technology and the business side that an API is just another integration tool. It's just middleware. That's all it is. It's just another like version of it. It will come and it will go. That's a very limited myopic viewpoint. Second one is the business staff are not trained, that they haven't been educated. So there's all kinds of rumors and misinformation that fill the void. I spoke with the chief, the controller, so like a CFO at a large company. And this is a very smart person. And this person gave me a definition of an API that was incorrect. Okay, so like, wow, this is coming from the top here. And then finally, no clear strategy for data security and governance. So it's an easy pushback from the business side to say, okay, well, maybe this is something that could be valuable, but is it secure? And then if that's not baked in from the beginning, if there's not a clear strategy for this, it's difficult to overcome, okay? And again, we heard things like, well, we have OAuth and users have to apply for keys. That's a very small step that is only the beginning of appropriate security. Second one, the focused and the transformed firms have a kind of readiness quality, right? So it's so much more than just the technical side. So first, they address the security and governance issues up front. Second, they have this evangelist who really communicates, who sets and communicates a vision. Like, this is what we're about. This is really starting to look like an organizational strategy versus a technical strategy. And then finally, this vision trickles down to develop a culture or a mindset that all individuals demand that data are available as services. They are just available, all data in the company. Amazon epitomizes and exemplifies this, but other companies outside of tech are starting to do this as well. Finally, we're starting to see the possibility that these leaders, the transformed and some of the focused, are setting new standards for their customers, pulling the entire industry with them, and setting a new bar, okay? And sort of creating a bigger competitiveness gap with other organizations. And this gap is getting bigger. So the question is, how will followers respond in industries that do not have big barriers to entry? And ironically, one of the industries that has the biggest barriers to entry is education, okay? So we in education are somewhat kind of buffered or protected in a way. Healthcare a little bit as well, so highly regulated industries. But many industries outside of that, they are really feeling this, this like potential issue here of how to catch up. Okay, last slide. So summary and next steps. So we identified the API infrastructure as the core entity for value generation. These three models, each with its own investment and return profile, and then several challenges and features. Next steps. So these are some questions that might kick off a discussion now. We have some time for that. So what theories might inform these FBM, the focus and transformed models of organizing? So do existing theories, can they inform these models, or is new theory needed? Second, is a model of organizing digital services becoming a model of organizing entire companies? Third, is the next wave no-code API integration with continued acceleration? And then finally, can APIs be used to mitigate negative externalities of modern digital systems, such as sort of data security, cybersecurity, environmental issues, and so forth. So that's my talk. Thank you very much, and look forward to any questions you have.
Thank you, Nigel. That's really interesting. I mean, it's a huge topic, and it's a nice to see a kind of charting and through this, particularly for organizations. So I'll just open it to the floor. Do people have particular questions? Raise your hands if you do. I think while people kick off, I thought it was a very positive message you were putting forward as kind of a walkthrough to transformative organizations. But have you seen any limitations in that strategy? That are there any risks associated with companies at this transformative level?
Absolutely. So if you think about what Maersk is doing now, and their attempt to use APIs to support TradeLens as sort of a blockchain-based, I would call it a service ecosystem based on APIs. It's a cautionary tale, because if you think of another large industrial company that attempted a very similar approach about 8 years ago, which is GE in the US, and by many metrics did not achieve on their objectives, the risks are tremendous. The risks are platform-based in terms of will different parties sign on to this platform model, incentive-based, but then you also have the risks associated with the APIs themselves in terms of security, mindset, data, and all kinds of new challenges. So risk is another dimension, and I'm glad you brought that up. Absolutely.
Does anyone have any questions? I'm not seeing anything in the chat. I was wondering about the decomposition of this for organizations. It's like many organizations have a kind of stack-based legacy structure for their IT. And I just wondered if in your interviews, people had discussed how you mix an API-led transformative model with the legacy ERP system stack that's probably sat at the back of the organization, whether they're enclosing that in APIs and trying to hide it out of the way, or whether they're seeing a transformation of ERP. What happens with the systems of record here?
Yeah, so what we've seen is a pattern of focused refactoring based on real market demand. So an example would be a company that has a legacy ERP, like you mentioned, for decades, and it works okay, but it's time to move on. And not really moving into the API space unless and until the new cloud-based system starts emerging. So basically, the technology leadership can use that as a key motivator to tell the business side, if we do not embrace a new infrastructure beginning here and expanding outwards, this project will not go. It's a necessity. So that's one of the routes that we're seeing. It's obviously not ideal for those seeking to kind of be at the leadership side of this. But for many companies, I think it works quite well. You know, there's another thing you raised, and I'm a bit, after the discussion by our logician in the house, I was a bit, I guess I was wondering if anybody would say anything about the language quote that I gave, because I know that's not necessarily a commonly agreed upon way of thinking about this. I also was wondering its relation to the decomposability idea in terms of so this would be the tension. When we think of a common modern digital system, you know, like an app on your phone that talks to you, that is connected to other capabilities through APIs, is it a single connected app, or is it, I'm sorry, system, or is it a set of systems operating together? In other words, where is the boundary with these pervasive distributed systems? How can we set a boundary, and so that we can even begin to talk about interfaces between boundaries, rather than interfaces between subcomponents of the same system, right?
Yeah, I think it's a my daughter's got a Spanish test today that she's been dreading, and your point about language assumes that within an ecosystem people talk or translate or understand in the same way. And one of the things that really interests us is kind of an incongruence between an understanding of what the API is from one side and it's an understanding on the inside. And while the technical kind of description might say, you know, very clearly you put this in and you get a JSON out, there's more to that. And I think it'd be really interesting to, even within organizations or within ecosystems of organizations, to sort of explore that. And David, who's turned his video back on, the logician and the logic, the rules that we've been exploring and some of the work we've been doing provide very precise descriptions and definitions associated with that. But then when you scale that up to business level problems, it's kind of interesting to think of it in terms of a grammar and a language, I guess. Yeah, it would be interesting to sort of discuss that, I think, in great length, because I think language is a nice way to describe it, because we've got very clear, we assume that we all talk the same language, yet we clearly very much don't. And I think that's really, it's so culturally situated as it is within organizations. So yeah, David, do you want to?
Yeah, and just one
hands as well.
One little thought on that. I mean, yes, absolutely, completely agree with all that. On the other hand, I think it's worth just pausing to note that even if you assume that there is good language agreement and good shared understanding, it's still difficult to get all these things working in acceptably robust, rigorous ways. So there's something to do even in the presence of those assumptions, even if they are a little bit unrealistic, as a first step, if nothing else.
Yeah, absolutely. I couldn't agree more, I think. Hans, did you want to join in on that? Sorry.
No, completely different question.
Okay,
if I may. Because Nigel, you asked for theoretical perspectives, and from a completely different angle. Have you considered, approaching this from perspective of transaction cost economics, and in the sense that interactions through APIs may reduce transaction costs and thereby also have an influence on the boundaries structure of firms and at markets. So, well, any thoughts on that?
Yes, absolutely. It's interesting to think about this as part of an evolution with Tom Malone's work on electronic markets and hierarchies, TCE, and so forth. And I think that is a useful approach. There is something in the way that this enacts itself, though, that gives me a sense that maybe there might be a disjunction. In other words, there might actually be some new phenomenon here that may not be adequately, I guess, described or explained by some of these existing ones. But thinking about it as another wave of this TCE, right? Asset specificity and this kind of thing. Yeah, I think that's useful. Thank you, Hans.
I was thinking, I mean, there's been a lot of the ecosystem debate around things like the mirror hypothesis and various others, but I was kind of, you always bring your own hammer, but I was thinking the kind of the stuff I did on digital coordination, where you're seeing multiple parties negotiating through what they think the past of the technology, the inertia of the technology, and what they imagine the future of the technology might be quite useful to look at. But yeah, that's just me selling my own papers, I think. But I do think there could be something interesting there. And Rosaire, the things that Rosaire is about to present, where we're talking about the growth of an ecosystem, I think will be highly relevant because it describes and talks to the interaction that these APIs explore and how they show the relationship between parties as being not as simplistic as is often assumed. I think that follows beautifully on from the work that you've just described, Nigel, where there is so much more complexity to perhaps the kind of boundary resource or platform literature that has been describing it so far. So I think, if I may, I'll just segue nicely into Rosaire's presentation, because I think it would be nice to follow that, and we can continue this debate afterwards, if that's okay, Nigel.
Cool.
Yeah,
thank you.
Great. So Rosaire, would you like to sort of kick off? And Rosaire is a postdoctoral research fellow at the LSE on the IRIS project and has been leading lots of the pieces of work that IRIS have been doing in this space. So I will allow Rosaire to start introducing the work.
Thanks. Maybe just I take the opportunity to make a comment in relation to this idea of the language. And I guess my background long time ago, my studies were on language and linguistics. And I wonder if maybe the metaphor of the dictionary more than the language per se might be more useful in trying to think about what the effort of translating means and how many times translations are not perfect and they are difficult. So as somebody who is not speaking my first language here, I can attest to that. Interfacing and speaking other languages brings complexity to that. So maybe that's where we will see that there are some frictions in our presentation. We will see that there are frictions in, let me find the presentation. So we will see, how in interfacing there are frictions. So we will see maybe the less smooth side of things, or let me see if I can find. I think this is the one. I had so many windows open as usual. So I think that's it. Yeah. Good. So we will be presenting a paper that it's a work in progress. It's in a revise and resubmit process, and We are trying to make changes according to the reviewers, which is always a bit difficult. So we are shaping a bit the way we present the findings. So bear with me, and if you have any, ideas on how to improve the presentation of the findings, that'd be great. Above all, the finding side of it is still a bit work in progress. We indeed are interested, and it has to do with a special issue in which we are submitting our paper that talks about innovation ecosystems. So it's there that we are trying to how we are trying to frame and present our research. So we are looking at the role of interfaces in fostering digital ecosystems, and we highlight this idea of ecosystems as being as evolving and changing. So therefore, we take a more of a I'm about to say processual view lightly, as in we are not taking very much here a processual theoretical perspective, but yes, we are looking at the changes over time. And we're specifically looking at the online travel service ecosystem. This is, as you can see, a co-authored paper. So in a nutshell, just to explain the story, in case I run out of time, and because it's quite a complex ecosystem that we are trying to study. But in a nutshell, you might remember when we were able to travel, that was a while ago, right? So when we were able to travel, usually we wanted to book maybe a hotel room. In the 90s and before that, probably we would go to an online travel, into a travel agency, and we would try to find flights, hotels, etc. Or maybe we knew the hotel that we liked most somewhere, and we would just call and reserve a room. That started to change in 1995 when the first online travel agencies were created. So we see the creation of hotels.com, booking.com, which they describe themselves, and I find this interesting, as a web-based marketplace that allows consumers to research and book travel products and services, including hotels. So in that sense, they present themselves very much as a platform, as a two-sided market, yeah, in which you have an OTA, and you have consumers looking for a hotel room, and you have hotels that are trying to, offer their rooms. And there is, of course, the need of booking this room for them. So that is this simple idea of the platform that matches offer and demand. In fact, we see that over the years, and that's what we analyze, we analyze the process of growth of a whole ecosystem that all is doing is matching offer and demand and booking hotel rooms. So here you can see how in 2021, there are different ways by which you might want to book a room. You might be reading a blog from a blogger, and you see an advertisement that leads you to a meta search such as Kayak and so on, where you see where you can book your rooms to that hotel that this blogger was talking about. By the way, all this involves that the affiliation platform is doing personalization, so it's matching well the reader of this blog with the sort of hotels they might want. And also, we know that these affiliation platforms connect with other social platforms. You might be a user of Facebook, and these recommendations are related to your uses of Facebook, etc. This meta search connects to meta search is basically aggregating the offers of online travel agencies. So when you only had online travel agencies and a hotel, here you have on the front end, if you like, of the user, you have many more actors, but also in the back end, you have many services that are provided to hotels that cannot deal with the whole complexity of dealing with the whole digital processes and even uses of APIs that are needed for the real-time price and availability, and also the booking processes. So what we can see is now, in a sense, what we are trying to show here is not the whole ecosystem. It's just trying to show if I am, as a user, going to book a room, probably my attempt to book a room would, in a sense, engage all sorts of interfaces. And here is where we are trying to show with this representation. So the paths that would be triggered through interfaces in terms of sharing data, sharing information, services, capabilities, analysis, etc. So basically, our research is about trying to understand the role of interfaces in this growth. And the contribution of the paper, therefore, is looking at the strategic role of interfaces in the dynamic growth, as we say, we see it as dynamic, the interface and the co-evolution of interfaces and the ecosystem. And in doing so, we hope to reconceptualize interfaces in digital innovation and move from a perception of interfaces as understood from a platform literature, which I will now present or discuss, into a more ecosystemic view that we understand as kind of moving a bit beyond what the platform literature has told us. So basically, as I say, this paper is about trying to understand the role of interfaces in innovation ecosystems. Innovation ecosystems have been discussed for many years, and there are many different perspectives. But in a nutshell, what all these different perspectives would agree is that an innovation ecosystem involves the creation of value by various organizations or actors, which they would not be able to create independently. And that's the key point here. If you have an organization that creates everything, but then sells something to another organization, that would just be kind of in terms of a market transaction. That wouldn't be an innovation ecosystem. In that sense, ecosystem members are seen as self-interested, so and not hierarchically managed. And yet, though, they are interdependent in the creation of products or services. And these interdependencies, some authors would argue, and we agree with that, these interdependencies are not just dyadic, one-to-one, but they are multilateral. So the effects on what A does affect B and C, and the other way around. So for A to realize their value proposition, B and C also need to do something conjointly. Therefore, for this literature in general, understanding the mechanisms that sustain such relationships and interdependencies and coordinate action, because we are talking about self-interested actors, they become paramount. So it's this idea of understanding how can you hold all this together if we are talking about independent actors. And it's here that this literature positions the term of interface. So interfaces are seen to play a key role in structuring relationships in innovation ecosystems. Why? Because they help coordinate the independent development of components. More specifically, the literature that refers to interfaces is literature that is interested in the concept of modularity. So standardized interfaces, and we should add also that they should be made publicly open or available to others, are seen as design rules that ensure the recomposition without predefining components in modular architectures, and therefore that allow the aggregation of components into a coherent whole of components independently created by self-interested actors. This sort of understanding comes from from literature that has been called platform literature or platform ecosystem literature. And it is here that the interfaces have been thoroughly discussed. Also in our literature and information systems, we have seen in the recent years a strong influence of platform literature. And also we've seen how interfaces have been conceptualized a bit further, looking at more social and regulatory dimensions as boundary resources. But again, if we take one of the key definitions in our discipline, interfaces are defined as, or boundary resources, sorry, are defined as the software tools and regulations that serve as interface for the arm's length relationship between the platform owner and the application developer. So again, in line with this literature that comes from product innovation. Therefore, from something that is about coordination of product innovation, we see that it is seen as a strategic, as having a strategic role. Interfaces have a strategic role as governance mechanisms and strategic tools for platform owners as orchestrators of distributed innovation in an ecosystem. This is how it has been mostly been defined. I'm simplifying. There is literature questioning some of these things, but this is the dominant way of defining interfaces in this context. So implicitly, this literature, we argue, sees interfaces as design rules. That's how they defined it. And in doing so, there is a tendency to assume that interfaces are the result of a rational choice of a platform architect, which is the central actor, and they do it in accordance. So this definition of the interface is in accordance to their focal value proposition. In addition, because literature on innovation studies specifically tends to come from this idea of platform comes or is influenced very much by an interest in product innovation, interfaces tend to be seen as, so to say, a glue. This is a sort of view of interfaces that is also applied, for example, when you talk about the car industry, right? That allows other actors, other organizations to build doors that will attach very well to your car. In the same way, digital innovation is seen as a recombination of software. So in that sense, technology and platforms are seen as products that can be recombined in a Lego-like manner. Another characteristic of this literature is that implicitly it assumes that interfaces allow for a sort of gravitational pull. They allow you to attract innovation. So you are the core or orchestrator, you have a focal value proposition, and you're trying to attract other innovators, which are seen as complementers. In addition, in general, this sort of literature, we say, takes a bit of a static and platform-centric view of ecosystems and their interfaces. However, there is literature that discusses innovation ecosystems that takes other flavors that we feel are missing in this literature that discusses interfaces. So drawing on some of the literature and adding to it, we argue that in ecosystems, interdependencies are not only cooperative. So platform literature tends to see the platform a bit of in a vacuum sometimes when they discuss these ideas of the platform and the complementers, whereas they are in competitive markets. Moreover, we argue, like other literature, that products and services exist in relation to other products and services, and that's how we see interdependencies taking place. It's not only products, but also services, therefore. In addition, in our view, innovators leverage a range of external capabilities and assets available in the ecosystem, and therefore integration becomes an important source of innovation per se. Finally, we take a view of ecosystems as dynamic, and also their actors are changing. So there is, we argue in our paper, an unclear single platform leader when we look at our ecosystem. And we see that over time, roles keep changing, and also the interdependencies between different actors. In addition, we argue that we need to see APIs in this context, considering another element, a very important element of software interfaces, which is that software interfaces are not just standards that allow for two systems to be put together, but more importantly, maybe in this context, is that they allow for the exchange of information between two computer systems. And therefore they provide, as David in fact was arguing as a computer scientist or logician really, they provide access to computer resources. So the strategic significance of the API economy is less about an IT mindset of connecting apps or putting together software, but more about exposing and monetizing information, digital assets, and services beyond organizations or beyond the organizational boundaries. As a strategic tools, in addition, we argue, they are also used in a competitive manner. So we are trying to look at these dynamics in which we can understand the use of interfaces strategically, and therefore for competition and cooperation, as we will see. Our research questions follow from all this. So basically, we're trying to see how interfaces foster or participate or co-evolve with digital ecosystem and new forms of value creation. And we also look at the multilateral relationships that get established and how these change over time, and what's the role of interfaces in that case. So for this, we draw on a case study of the online travel ecosystem. I think we have almost more data than we can handle, and I will go a bit quickly on this. I won't spend too much time, but basically, as we say, we are studying how the digital online ecosystem has been changing over time. And we draw on a lot of data, and Erica has been key on that. She did her PhD on TripAdvisor. Here we have moved beyond TripAdvisor, and we have been looking much beyond that. But basically, we have drawn on the information that we can find on the documentation of APIs in the programmable web. So we have downloaded all the APIs that refer to travel, and we have looked and classified these APIs, also to try and see what actors these APIs were connecting. We were looking at the web pages of these actors that we're using to try and find out what the partners, connectivity partners were. So there was lots of work on that, also going to the Wayback Machine to try and see how these connectivity partners had changed over time. Also to get an idea of the whole industry, we have drawn on documents, and a lot of it comes from Skift, which is a specialized source of information on the travel industry. With that, basically, we have tried to make sense of these changes in the creation of interrelations and with them. So all these APIs that kept growing, or the interfaces kept growing over time. And also we can see how new actors appear. So as I said, from 1995, where we see the first online travel agencies, and 96, the GDS, which are the global distributor systems, which typically used to support flight booking. They also started supporting room booking. And then in 2000, we see TripAdvisor, which is the first social travel platform that appeared in 2000. So here, very simply, what we see is that online booking appears in the scene from 95 to 2000. Later on, we have tried to divide how this has changed over time. We've done a network analysis of these APIs and the connections, trying to see how from 2001 and 2009, I will explain a bit more. I can't go too much into detail. As I say, we have lots of data of this growth, but we see new actors appearing, and we have tried to see how these new actors appear. But in 2010 and 2014, look at this, we have many more organizations and companies that enter into the ecosystem, providing services at the front end and at the back end. And all these connections that we can see here are connections that take place through interfaces. Basically, though, I don't know how much time I have, Will. I've not checked, because I've not...
Got about 4 or 5 minutes left.
Okay, then I won't go too much into detail on this, but we are trying to show how over time, as I say, new relationships are created and new actors appear, and that's how the ecosystems keep growing, new actors doing new things. But mainly then, in terms of analyzing all this data of these changes over time, what we try to do is to try and see what sort of, we have tried to abstract these sort of interfaces and what's their strategic role. So let me start by how, as I mentioned at the beginning, we used to have, travelers, online travel agencies, and hotels, right? Well, very soon, when more and more actors or new players saw a possibility to enter the market, and there was an increase of OTAs, meta search, they were new actors that appeared, that what they were trying to offer to the end user was aggregating all these offers of OTAs into one platform. What did they do? They were trying to penetrate the market, and they did what we call, what we have decided to call surreptitious interfacing. So basically, they were trying to become platforms. They were trying to intermediate between the OTAs and the end user. So here we don't have a platform that is creating an interface to attract complementers. On the contrary, it's using the possibility of web scraping. So that's why we call it surreptitious interfacing, as a way of exploiting digital resources of others without their consent. Once they managed to do that, afterwards, OTAs realized that they somehow were becoming more and more interdependent and dependent on meta search, because end users were going to the meta search to try and see the different offers that OTAs were given. So at the beginning, OTAs resisted this interfacing. However, afterwards, there was an agreement. So there was a collaborative bi-directional interfacing by which there was a mutual exchange of digital resources. It didn't go one direction. And also there was an agreed interface between these actors. It was not one platform defining, it was two important actors at that moment defining and agreeing on ways of interfacing, so that meta search could aggregate offerings. That was their kind of business model. On the other hand, OTAs accepted this because the meta search were becoming successful intermediaries. But then we have realized that as I was saying, with the growth of the ecosystem, we can see is that more and more there are new actors that appear that try to provide new services, so kind of added value, some of which is done through the interfacing as such. So in the interface, we find that there is data analytics going on in the transactions that take place over the API. For example, one of them, and again, focusing on this example of the meta search and how increasingly they were gaining power, if you like. At some point, because there were too many OTAs, meta searchers decided to introduce automatic bidding, by which OTAs, if they want to appear kind of towards the top of the meta search, they need to pay, they need to bid. And this is all automatically done. It's an automatic bidding. So at the beginning, from OTAs being the platform, if you like, being the core of the ecosystem, they became challenged somehow by meta searchers that not only had become intermediaries, but now they made them pay. The OTAs had to pay, had to bid to be on the top. By the way, all this meant that OTAs, some years later, found the support of other actors that were providing services so that they could bid at the right price. Yeah, so we do see that this generated new actors that were offering services to improve this. We also have seen that there are what we call collaborative network interfacing, by which a service can be offered by combining resources from a network of actors. So this idea is that interfaces are bi-directional is not the case. So for example, when a channel manager, those are actors that appeared later, receives a direct booking call from a meta search, the channel manager calls the property manager to see availability, then the revenue manager to get the price, and then calls an IBE to get the link to the hotel booking page. So the channel manager then puts all this information together and sends it back to the meta search that called with this query. Yeah, so here we can see that APIs kind of go in a network way to offer services and recombine all these digital assets or digital resources that are provided by a range of actors. Also, we see what we would refer to as interfaces seeding or spreading. And that's something that we see in the more recent years. And this occurs when an interface is offered for other actors to use elsewhere. So this is done typically via API platforms, such as nowadays GDS APIs, Paleo or Expedia offer APIs for others to use. But this is not done with this concept of the platform literature that would argue that the platform creates interfaces so that others can aggregate or attach their innovation into their platform. What it allows is third parties to do mashups that will be running in other platforms. So the strategic aim for those doing interfacing is to attract customers by creating connections beyond their own platform or organization. So encouraging others to create the connections that will kind of then lead to them dealing with the booking and so on. But innovation as such is done by a third party, and it's done elsewhere, not really, and it's not orchestrated by the platform that is offering the API in that case. That, by the way, creates interdependencies that the API provider is not controlling. Yeah, so a developer might be mashing up different APIs without that offering the API really knowing. But the counter example or the counter view of this interfacing is interface mashup. So if you have some actors that are offering APIs, you can recombine those APIs to offer a service, right? But what I want to highlight here is that you have even big players that are seen as leaders of ecosystems such as TripAdvisor, so typical platforms, that they are doing this mashing up. So it's not that they are offering APIs for complementers, but that they see that they can offer a service by recombining APIs from other actors. With all of this, I'm reaching towards the end. Basically, what we can see through our analysis is the growth of an ecosystem that keeps changing. And we can see that there are hubs and platform leaders that keep changing. It's not clear that there is one platform leader kind of orchestrating the whole ecosystem. In addition, we can see that new actors and relationships keep emerging over time. And also we can see that actors keep changing, and also the boundaries of the ecosystem keep changing. Towards the end, we see nowadays, for example, Google has become a meta search. So if you go to Google and you say hotel in London, you can do the booking directly in Google. Moreover, you can see that actors keep adapting. So at the end, if you look at the evolution, what this company is keeps changing. Yeah. So what, let's say, an online travel agent is now or was then has changed, or a GDS above all, which was an incumbent, was there from the beginning. They had to adapt and change, and now they are offering APIs in ways that probably have to do more with reacting with the environment. That's really this idea of I have my focal value proposition and I just need to attract some complementers. Also, what we can see is a multiplicity of interface designers, therefore, and users. So it's not that one offers and the others use. We see that it keeps changing, and the same actor or organization might be offering and receiving services, data, and even using or developing APIs. In a dynamic that we would call of push and pull. It's not only that you are trying to pull, but also you are looking for resources out there. So interfaces are developed and used to create and capture value in various ways. That's what we see. So for example, services are created by mashing up data gathered through various APIs, or we find also interfaces of interfaces. With the growth of complexity, we see that some actors facilitate the use of APIs by creating APIs that aggregate APIs. We also see that interfaces, some of them are spaces for economic exchange because they involve transfer of value. Finally, therefore, that's the last, what we try to contribute with this paper is reconceptualizing interfacing in digital ecosystems and innovation ecosystems. First of all, we see digital interfaces as defining standards for the exchange of information and resources. So it's important for understanding the growth of our ecosystem to understand that APIs facilitate on-time circulation and repurposing of digital assets, services, and capability, and not just a recombination of software. And APIs don't only facilitate the aggregation of new apps into operating systems, but crucially, they allow organizations to easily expose information, data, and digital assets. We see interfacing, and we tend to use this processual view because we see the ecosystem changing with interfaces. So we use the term interfacing to highlight this. And we see that the strategic role of interfaces cannot be reduced to coordination of distributed innovation by a core platform. Interfaces facilitate forms of innovation that do not involve adding value to a platform, but the repurposing, recombination of digital resources and capabilities. It is also, interfacing is dynamic because it's varied, it's reactive. You see actors looking for new opportunities or reacting to competitive challenges. It is partly emergent and it co-evolves with the ecosystem. It's also active interfacing because we don't see interfacing as a glue, we said, neither just as a flow of data. We have interfaces that add value. The interface as such is adding value through analytics, bidding, etc. Finally, therefore, this view of interfacing is in connection with a dynamic view of interfaces and ecosystems, which we don't see as centralized, but we see an emergent dynamics of ecosystems, of actors that seek new opportunities with multiple interdependencies constituted through interfacing that is of the push and pull sort of direction. So this is it. Thank you very much.
Thank you, Rosetta. I hope everyone will agree. We're running a little over time, but I think it would be fair to allow some questions of Rosetta, if that's okay, with Hans. Yeah. So do anyone have any questions? One's just come through on the message. Let's have a look. Lucas, do you want to come online and ask your question? I'm not sure if Lucas is there. Lucas says he's in the library with his exam, my exam. He's taking my exam in a minute. Okay, fair enough. Let's ask his question. Healthcare ecosystems need to share patient data freely with all relevant stakeholders within the system to get a holistic picture of the patient, especially important for treating patients with chronic conditions. Therefore, platform owners cannot charge and sell data, i.e. happens in the travel as happens in the travel ecosystem. I'm wondering which business model could platform owners adopt in a healthcare ecosystem where data needs to be shared freely while still being profitable?
Yeah, of course. Yeah, we are dealing more and more with economies that are based on repurposing data, and of course, a good question is where does this data come from and what happens with privacy? Moreover, in our ecosystem, it's not called this way, but the growth can be conceived as marketing growth of the ecosystem, because basically we have offer and demand, and it's about matching and the better matching. And not only that, we have bidding, in which you are monetizing the fact that there are many offers and so on and so forth. This is a key question. I agree. I think we are building a whole economy based on sharing data, and of course, not all data should be shared. Oh. So I don't know if I've
never actually seen you before, so it's nice to see you. First time ever.
Sorry.
I don't know if anybody has more insights on what would be the best. Recently, it was in the news, by the way, that it seems they are trying to sell some of the data in the UK that they have in the health systems.
Yeah, I think that
very good.
I think this more nuanced conversation around interfaces will become more and more relevant as artificial intelligence gets applied to the data that's flowing through interfaces and then becomes much more consequential. So I think there is a kind of a cusp now of that merging of data. Nigel, you had a question. Do you want to ask it?
Yeah, just a quick one. It would seem that with this sort of continually evolving and emergent nature, which I think is a fascinating storyline. I can't wait to read this paper. That's awesome. How do organizations keep up in terms of things like governance and things like product management? Because it's not that stereotypical platform that we read about at all, right? So I'll stop there. Yeah.
I guess that partly that's the story maybe that we are trying to tell. If you see how OTAs started as being the platform, and then they are challenged by meta search, and now they need to pay to be, presented there in the meta search. And then once they see that there is value, Google comes and they say, hey, I'm going to be the meta search now. You can see that, yeah, the competition is high. Somehow one has the feeling that there is, I like this idea of how it started with just offer and demand, and all this ecosystem has grown, and it looks like it's about trying to seek the opportunity in it, right? And that's why I find that platform literature many times tends to give this very cooperative view about innovation is about attracting other innovators that are around the world, and here it's much more less smooth. And we can see how, for example, GDS, which were incumbents, they were the ones that had the back-end systems of for booking flights. That's how they started, and they were kind of pioneers on that, right? And how they have had to adapt a lot. Now they are kind of they are kind of an API platform, trying to provide APIs as a way of having others using their APIs so that they can still keep alive, so to say, in the ecosystem. A story that we are not explaining also is that with that there have been lots of mergers, companies buying other companies and so on. We didn't go into that. So I guess that's a partial view. It's a partial view that looks at the role of interfaces. But yeah, I don't know if I have answered sufficiently, but yeah, I feel that there is lots of constant adaptation. So interdependencies, that's another thing I think we want to highlight. Interdependence is also dependence. So more and more you have these services that are provided, depending on others being in line, but others are looking meanwhile for other opportunities. So yeah, I think that puts probably businesses in positions that are not that easy.
I'm very conscious of time, but Susan's had her hand up a long time, and it would be nice to include, at least hear the question, even if it's going to be a very long answer. Susan, hi.
I'll just keep it short. Really nice presentation, and I think it also reflects a lot my own experiences from research. And I was really fascinated also by this. I can't remember what you call it, but these interfaces of interfaces. And is that also a response to the growing complexity? So as more and more APIs, I think it's also a way to manage with the issues of this complexity, so that you only need to use one API instead of tons of it. Is that also something that you maybe saw over time? I think it would be nice if you could show that. And that maybe also means that this is something that we will see more and more, and maybe should study.
That's an element that maybe is, I don't know, I feel that this paper has so many threads that the challenge has been to try and focus, to be honest. But there is part of it in the explanation that now I had to rush. But for example, meta searchers appear as platforms. They create a platform that tries to deal with the increased complexity. How do they do that? By using interfacing, and trying to aggregate into a platform. However, later on, with all the complexity of the ecosystem, we find that there are new actors, such as the channel manager, integrator, or aggregator, that indeed what it tries to do is to help OTAs and meta search to deal with all these APIs that are out there. So they do what we call interface of interface. So in that case, so first we have a platform dealing with complexity. Here we have an API of an API, so to say, or an API of API, sorry. So here is the creation of an API to deal with complexity. So indeed, we do see this process of increased complexity. Then one of the kind of business models, so to say, is to try and deal with complexity, narrowing it down. But we have other ways. What about bidding? Is a way of dealing with complexity, and moreover, monetizing this dealing with complexity, right? There is an element of that. We feel that that's not only it. So we have also APIs that are used to provide analytics, etc. So we try to keep this as part of the story, but not the whole story. But maybe you are right that would be enough.
That's
Thank
super
you,
interesting.
Rosé. I'm going to move us on because Hans has been waiting,
Sure.
and we need
Thank you
to
all.
sort of get
Yeah.
on. We're still running a little bit behind, quite a bit behind, but that's great. There were some other questions as well. I'm sorry to people who couldn't ask their questions, but Hans, it would be lovely to hear from you, please, if we may. Hans is, where am I? No, so I introduce you correctly. He's Professor of Innovation and Organization at Kin, who's a sponsor of Diiesl. So we're really pleased to have Kin as part of Diiesl, and this is a very broad church. So we'd love to include any institution that's kind of keen to be part of this, and also works at the Amsterdam Business Research Institute, which I think Kin's based out, right? Yeah. So over to you, Hans. Thank you so much.
Yes, thanks, Will. Thanks for having me here. Indeed, Professor for Innovation Organization at the School of Business and Economics, Vrije Universiteit Amsterdam, in the Kin Center for Digital Innovation. The story that I will tell resonates in several ways with Rosair's. Different setting will be in smart homes, but equally focused on a situation where it is more an ecosystem and all kinds of cross connections between platforms and ecosystems, instead of that very neat imagery that the platform ecosystem literature sketches of a core platform and its set of complements. Well, I think also what Nigel indicated and what you said, Rosair, the world is getting more complicated than that, and that brings nice research opportunities. And we will be focusing on the role of the user in that area. So this paper is a joint work, most of the work actually being done by Katrien Bonner, who is now on maternity leave. So it can happen any moment for her, but so that's why I will be presenting it, and then also together with Frans Veldberg and Fleur Degen. It's work in progress, so any comments are appreciated. We position it also in literature on innovation ecosystems, where, as Rosair also explained, this idea of complementarity between products is key. Complementary products offer more value when consumed together, and the stereotypical image is that of a platform core, like a video console, a video game console, and the complements being the video games. And that firms seek to expand their ecosystem by opening up their APIs, like you also explained, Rosair. Our point is that for users in several settings, the complexity is not being resolved by firms and their ecosystems. So if this figure in the right-hand corner of the slide shows a situation from a user's perspective, for instance, in smart homes, but also in other settings, that in a user's system of use, a user can have products or services originating from different ecosystems that may be unconnected as of yet. In smart homes, for instance, one influential platform is Apple HomeKit. There are many others, but they don't incorporate all possible products that people may have in their homes. Here, the metaphor that Nigel introduced of the languages is very appropriate, as I also will show later, that many of those products in smart homes, they speak different languages, different interface protocols, which is a challenge. Yet users, they may have a system of use composed of products, services from different ecosystems, seeking to integrate that. So here we draw upon a distinction that Ulla Hemfordson and colleagues introduced between combinations as designed by firms in their ecosystems and the combinations in use by users. So what we want to know is, how do users contribute to the creation of complementarity? situated in this smart home setting where there's a range of communication protocols, different radio channels, you could say. Well, we know about Wi-Fi, Bluetooth, but many others. And sometimes products can connect through the radio channel itself, sometimes through APIs. But for users, this often creates a challenge that you may have products that do not communicate immediately with each other. There are hundreds of thousands of smart home products out there now. So that's the setting and the challenge for the user. We focus on two companies in a bit more depth. First, Philips Hue, now owned by the company called Signify, independent company. Before it was Philips Lighting, and Bosch Siemens Hausgeräte with their Home Connect platform. We did earlier studies with Philips Hue. Susan Hill-Bolling, who just asked you the question, was there. With her, we have a nice paper also on how Philips Hue got interconnected in an ecosystem of ecosystems, creating issues of, let's say, also new opportunities, but also risks of that all these linkages with other platforms create, because they need to be maintained. They may break down. They kind of capture you in this web of interdependencies. But so we did prior work with Philips Hue. We have Katrien now very much embedded with Bosch Siemens Hausgeräte and their Home Connect platform. Different data sources. Well, just to show you, to those who don't know, Philips Hue smart lighting system, many apps, and you can connect it, for instance, with sound. So you can connect it with music and many other applications. Interviews with Signify and BSH employees, documentation, observations, interviews with users. In interviews with users, we used these cards that you see on the right-hand side, where we asked them to represent their smart homes. Some cards, they have specific brands or types of products, and they show which smart home products they tended to use in combination, what were more like islands in their smart home, and they explained to us how users more and more integrated these different products in their system of use. Then we used data from two intermediary toolkits that play an important story. One, IFTTT, if this then that, which you may know, and Olisto, which is a Dutch similar service that also allows firms and users to make connections based upon firms' APIs between a range of different products and services. From Olisto, we got a data set of more than 100,000 combinations made by more than 40,000 users. Combination of qualitative and some quantitative analyses, as I will show you. What basically triggered us in this research, as we had worked with Philips Hue as well as Bosch Siemens Hausgeräte, is that both said integration is great. Here's our API. So the BSH manager said third parties should integrate our products via our API. Philips Hue manager said, sure, we provide our API. They know what they have to do. They know what they have to do. No, said BSH, sorry, you have to do the work. So for both organizations, what we observed is that they were willing to do the integration work with what they saw as their main partners, where they saw the greatest benefit, maybe for 20, 30 partners. But that would be about it. And for both of them, they said, well, no, this is too much work for us. You know, we can't make an integration with each and every product. So we knew that BSH and Philips Hue had been talking 2 years. They didn't really make it possible. Then they got into contact with this company called Olisto, so this Dutch platform similar to IFTTT. And they took this role as being in between, connecting through the Philips Hue API to the BSH Home Connect API, and making it very simple for users to make that connection, to program that connection, as well as program connections to many other products and services. What you see in these graphs are the number of combinations made by users, and in some cases by firms, with the BSH products, smart washing machines, smart coffee makers, what have you. That's in total about 100 combinations that are used maximum 200 times by 200 different users. Philips Hue on the right-hand side, much more popular, about 1,000 different combinations programmed by users, used maximum 16,000 by 16,000 users. What we were interested in particularly was this role of the users. How do they go about in making their combinations? And in our interviews, it was clear that you have these enthusiasts, the tech-savvy users who program their own home. You know, a lot of do-it-yourself work, 20,000 lines of code to program my own home, and all kinds of different combinations, like this person, guy, 95% these are guys, I don't know why. When it starts to snow, SmartThings turns on a smart plug to melt the snow on the roof. You know, they come up with these different kinds of combinations of given products that are recombined in new ways. And they gradually expand this, as we could see with these cards that they showed to us, and connect hitherto unconnected products in their system of use. They could program it themselves if they were tech savvy, but more and more enabled by these toolkits provided by IFTTT and Olisto, which reduce the technical skills needed, make it very easy. But what we argue is that to realize this complementarity, you do not just need the technical connection. Most of all, you need to see the value. And that's a big struggle for many companies in this smart home environment who create technical compatibility without a clear idea about where's the actual value. We have connected coffee makers, connected washing machines, connected everything. Where are the actual use cases? So one of the arguments in the paper is that the role of the users who make use of these toolkits is to do value finding, to find valuable use cases, valuable combinations. And they do so as anchored in their system of use. Now, this concept of system of use is recently introduced by Eric von Hippel, the user innovation thought leader, who says users, they do not focus on individual products. They always see products in combination with other products, routines, behavior, always in context. So what we saw is when we consider the combinations that users make through this Olisto toolkit, is that they typically make more complex combinations. Sometimes 2, sometimes 3 products, sometimes 4 products, sometimes even more. And they do so with their understanding of their own system of use. And they typically relate the combinations that they make to their behavioral routines, or even innovate their behavioral routines with that. So it's like in this example, we have a baby and some things need to happen every day. So they program lighting in combination with temperature in relation to the bedtime routine for the baby. The other example of snow melting on the roof when the weather service indicates that there will be snow, or that there is snow. An example of innovating a behavioral routine in a system of use. So what we then see is that users with a more complex system of use, who have more channels, they also make more complex, what we call more systemic combinations. And that they make a larger share of the combinations that they have in use, make it themselves. So indicative of that, the users, they expand the system of use and think of combinations of products as embedded anchored in that system of use. And if we then look at the interactions between users, firms, and toolkits, well, clear these intermediary toolkits, they enable the technical connections. But the users, they contribute by finding valuable use cases and inspire other users with that. Other users, they scan through it. What's possible? You may not, well, the example of having some heating your roof when the snow has fallen, or wouldn't be something that I would immediately think of. Well, in the Netherlands, we don't have that much snow, but in other places may be more valuable. So they inspire each other by seeing these combinations. Moreover, they inspire these firms. Firms can observe what are the combinations that users make through these toolkits. How often are they used by others? So in this sense, the users, they find the valuable combination, valuable use cases, and they perform a kind of a search function for those this identification of value, which is difficult for the firms themselves, and then enable that for, let's say, a long tail of applications. These firms are interested in the 20, 30 most valuable partners, but through these toolkits, they can identify, well, what could be a potentially really valuable partner, and allow users to make combinations with a whole, a larger set of products and services. And what we then see is that the more complex such a combination that is programmed, the less it is used by others. Again, because it's more likely to be idiosyncratic, tied to their own system of use. Trying to make sense of it in terms of a two-dimensional framework, of the creation of technical compatibility and the identification of value, both needed to create this complementary value. And what firms are typically strong at, creating the technical compatibility, but more difficulty in finding the actual valuable combinations. What this interaction with these intermediary toolkits the users does is that it helps them to see where valuable combinations could lie, and also simplify the work to make those combinations. For the users with their system of use, it enables them to, it simplifies the technical work for them. It doesn't require 26,000 lines of code to program their own home. It simplifies the work, but also they see the value that others identify with their combinations that they make. So together, the interactions between the firms, toolkits, and the users help to improve the complementary value in this ecosystem of ecosystems. Now, to the innovation ecosystem literature, we're advancing first this idea of the dual challenge of technical compatibility, which is more often the focus in combination with value finding, that users and these intermediary toolkits are important, especially in such a ecosystems context, where it's not just single firm with its own set of complementars, and that users play a particularly important role in finding value. And then we contribute to user innovation literature, which has so far been mostly focused on users innovating individual products to users creating combinations of products, thereby show the importance of this system of use concept, and also bridge the two types of user innovations, product innovations and behavioral innovations. That was it. 4 minutes left.
Thank you, Hans. That was a speedy way to bring us back on time, and a fascinating example. I'm sure we've all wrestled with 5 different types of gadgets at home, which now don't get used that much, I'm sure. But any questions? Nigel, there's lots of things going on in the chat as well, which you've been
very
contributing. So
very stimulating presentation, Hans.
Yeah,
it really got my mind thinking. I really think you're going in a very fruitful direction. I do have a specific question around the organizational perspective. So if we think of the maturity of like a smart product ecosystem, we think of like early stages. Okay, I'll have this smart product. Now I got to have an API. But it seems to be progressing more of like a Lego model, where the mindset of a product developer inside of Philips, for example, is going to be, how do I, and I think Will said this, enable a kind of open innovation to quickly determine the diagonal space, which is the sweet spot, right? I want to be upper right, exactly. So and get that from users, and let them know that the better they are able to create slightly generic use cases. So for example, you said the baby example. I can think of many people who would use this if it had some little bit of generic where you could flip a few. So to me, that is where we are going. It's fascinating, but I would just want to know you're doing the research, so what your perspective on that?
Can I just expand a little, because I think that's there is also, and it's good just because it's relevant. So sorry, and is the battle between generativity and control that Tilson talks about for digital infrastructures. And I was thinking that because of the combinatory nature of this, that there is, and the innovation of use cases, there's something more than just generativity, which kind of implies a network effect, as much as it goes beyond that form of generativity to this idea of combinatorial innovation and selling. I mean, also people seeing it, like we've heard here, oh, hang on a minute, I like that idea. So I thought you would, that would seem to fit again with the open innovation and the logic that was there. Sorry, Hans.
Yeah, let's see. I think there are 2 main challenges here in this space of smart homes. One is finding the actual value, the actually valuable use cases, and the other big challenge is the challenge of the different languages, the different protocols, and there's also some technical reason for that, the different radio signals that they use, Wi-Fi, Bluetooth, Z-Wave, Zigbee, 20 different, they have specific advantages. One, they either have higher bandwidth, but consume more energy. So you need to have a cable. You can't use it for every product, or they may be smaller bandwidth, more energy efficient. So it's not likely that they will converge on one standard in that regard. So the alternative option is to communicate through the web, through the APIs, but then you get issues of latency, reliability. People do not like it when you push a button for your phone and it takes a second. If it takes a second, you feel, oh, is something wrong? And if it would take 5 seconds, and you also become more liable. So, and so where is this going? Normally, we would expect more convergence. Through the logic of platforms, you would say we have network effects that are self-reinforcing. So there should be a few of those platforms who come out on top. In another study, we are following 94 of these platforms that all aim to be the hub of the smart home. Apple HomeKit and 93 others. And we see not the kind of convergence that we see in other platform markets. And we do explain that because also of these technical characteristics of these different radio signals, the fact that people do not change products in their home as often as they would do with, I don't know, if you, like the example that you provided was with the using different services to book your book some travel. That's something that you do anew every time. But when you have your window blinders, you will replace them 10 years later again. And then your washing machine, yeah, well, in 6 years' time again. So there's this legacy in people's homes, which also reduces this trend towards the convergence.
I think that issue of legacy is a really interesting one because we often see these so much in a kind of singular point of time, whereas we have, you know, the car industry is a kind of classic example of this. I remember talking to executives there who are saying, well, the lifespan of your phone is 2 years, the lifespan of the car entertainment system is 10 years, and we're trying to make sure that it will run for 10 years. This is a huge challenge that is a kind of a very different, particularly when you start embedding switches and bits of copper in walls. And we did some heating engineering work. You know, when you look at industrial systems, it becomes a massive, massive challenge of how do you change those old controllers. Any other questions? Sorry, I'm not trying to dominate.
If no one else has one, I've got another one.
Go on, Nigel.
Okay. Yeah, I think the industry dynamics here are so fascinating. It's unbelievable. So here's my thought. Does anybody know of a study that compares and contrasts what I would call almost monopolistic platform industries or duopolistic? So for example, phone systems, right? Versus others that are not that way and may never get that way. And then the attendant dynamics and implications for both the stakeholders, including the users, because this is real. I have struggled with the home, all these home issues you mentioned, Hans. I've struggled with them. And one of the things I see is that each one company wants you to have their app so that they can get the data better than the other one. This is another form of equilibrium. Well, they will never get to the platform. So I'll stop.
I think that's a really interesting, if it hasn't been written, it should be, and it fits with the things that Rosaire and I and the team are working on, in that there is an inherent assumption, from the dominant platform debate, that somehow an Apple or an Amazon will emerge. And therefore that zeitgeist has kind of permeated all our management thinking around these things. But I'm not entirely sure that, the travel ecosystem, that doesn't seem to be the case. We can frame it as though there are significant platforms at the center of it, but we're certainly not seeing that, I think, in there yet, obviously. But I can't imagine that happening. And I think this is perhaps another area where, are we going to buy the washing machine from the same company that we buy our heating elements and our car? And it's not likely. So
No, so we reflect on those questions, but only based upon the smart home industry. Not in this paper, but in another working paper. But the comparison would be fascinating because like you say, Nigel, I think this assumption that it will all converge because of these winner-takes-all dynamics is not happening in quite some industries.
Any last question? I think we did an amazing job to manage to come in so close on time. It's been a wonderful afternoon. I hope everybody agrees. Thank you so much for all our speakers. I think if there are people online who want to turn their mute off, we can all give a round of applause collectively on Zoom, or you can click the buttons for it. But yeah, I'd just like to thank you all for speaking. We've done, yes, there's a few people turning their video on and clapping. That's great to see. I think this has been a wonderful means of connecting a set of issues which are really at the core of this digital economy. And I'm so pleased that we're starting to engage with this issue of APIs within information systems and in other disciplines. And I think there's lots to be done here. And maybe this is a topic we'll return to with Diiesl. Thank you for everybody who's attended this Diiesl talk. This is a series of Diiesl talks with lots of partner institutions. We've got Exeter, Mark's on from Exeter. We've got LSE, obviously, and Kin are part of this, but others that I'm almost certainly forgetting. And it's a broad church. So if people are interested in the events, then we'll sign you up and keep you informed. But thank you once again, Anne. Thank you.
Thanks for organizing, Will.
No, thank you so much for attending. That's great. Thank you.